Welcome. Today we're going to take a math concept you probably learned a long time ago and stretch it like all the way to infinity. You ready for this?
So, think back for a second. Back to your first math classes. Almost every problem had just one right answer, didn't it? But what if? What if I told you some problems don't have one or two, but a totally endless number of correct answers? Yeah, that's exactly what we're diving into today.
So, first things first, let's start with what we all know, the world of one.
Okay, so you've seen an equation like this a million times, right? It's a classic linear equation in one variable. What does that mean? Well, we've got one mystery number x, and our one and only mission is to figure out what it is. And gam, there it is. The answer is negative 2.5. And for this kind of equation, that's it. There is one and only one solution. It's clean, it's simple, totally predictable. But you know, not all problems in life are that straightforward.
Which brings us to the complication. What happens when having just one unknown, well, isn't enough to solve the problem?
Okay, picture this. You're watching a cricket match. Two batsmen together have scored 176 runs. We know the grand total, but we have two big unknowns. What did the first guy score, and what did the second guy score?
And that is the million-dollar question, right? Did one score 100 and the other 76? Could be, or maybe 50 and 126, or 1 and 175. See the problem? If we only had one variable to work with, we'd be totally stuck. We need more tools in our toolkit.
And this is what that problem looks like when we translate it into the language of math. We'll say x is the first batsman's score and y is the second's. And just like that, we have a linear equation in two variables. It's a perfect way to write down our dilemma.
So, okay, now that we have these new kinds of equations, how do we actually deal with them? Let's build out that toolkit we were talking about, and we're going to start with what's called the standard form. So this right here is the official by-the-book definition. Now, it looks a little intimidating, but don't worry, x and y are just our two mystery numbers, our variables, and a, b, and c, they're just regular numbers. Think of a as the number that's hanging out with x, b is the one with y, and c is the constant, the number all by itself. The only really important rule here is that a and b can't both be 0. Why? Because then our variables would just, poof, disappear.
All right, let's actually put that definition to work. Take this equation. To get it into that neat ax plus by plus c equals 0 format, all we have to do is shuffle that 4.37 over to the other side. And look at that. Now we can see it plain as day. A is 2, b is 3, and c is, be careful here, negative 4.37. See? It's really that simple.
Okay, we've set the stage, we've got our tools ready, so now for the big reveal. What does it actually mean to solve one of these things? I'll give you a hint. The answer is probably a little different than what you're thinking.
This is the absolute key. We're not looking for a single number anymore. Forget that. A solution is now a pair of values. It's an x, y team that has to work together to make the equation true.
Let's test this out. For this equation we've got on screen, could the pair 3, 2 be a solution? And just a quick reminder, when you see a pair like that, the first number is always x and the second is always y.
So how do we find out? Simple. We just plug the numbers in. We swap out the x for a 3 and the y for a 2. So 2 times 3, that's 6. And 3 times 2, that's another 6. And what's 6 plus 6? It's 12. It works. So yes, absolutely, the pair 3, 2 is a solution. Okay, but what about a different pair? Say 1, 4. Let's run the check again. 2 times 1 is 2. 3 times 4 is 12. Add them up, 2 plus 12 is 14. That is not 12. So, nope, this pair is not a solution. It has to hit that target number perfectly.
So, let's recap. We know a solution is a pair of numbers, and we know how to check if a pair actually works. But how many of these solution pairs are there? 1, 10, 100? This, my friends, is where things get really, really interesting.
Okay, we already found 3, 2. But what about 0, 4? Let's check. Yep, that works. How about 6, 0? That works too. We can even get weird with it and use fractions, like 2, 8 thirds. Guess what? It works. We can use negative numbers like negative 5, 22 thirds. Still works. Are you seeing a pattern here? It kind of feels like we can just keep finding more and more and more.
And that's because you can.
Here it is, the main event, the big takeaway of this whole thing. A linear equation in two variables doesn't have one right answer, it has infinitely many solutions.
You know, the textbook we're referencing puts it perfectly, saying there is simply no end to the different solutions. I love that. We started in this simple world of one unique answer, and now we've ended up in this vast ocean of infinite possibilities.
Which, of course, leaves us with one last really fascinating question. If there are literally infinite solutions, how could you possibly see them all at once? How could you ever understand them as a whole? It sounds impossible, but it's not. And the answer to that question, well, that's a story for another time. Thanks so much for joining me.